to solve this question, rotting oranges. Okay, let me read the question. In a given grid, each cell can have one of these three values. Value 0 representing an empty cell, the value 1 representing a fresh orange, with the value 2 representing a rotting orange. Every minute, any fresh orange that is adjacent flows directionally to a rotting orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1 instead. Let me see the example one. So the input is so 2 represents rotten, 1 represents fresh orange, 0 is empty. I see, and okay, the length of grid is at the most 10. Now I think it is not very difficult because we can do very naive approach because the number of cells in the grid is at the most 10 times 10 equals 100, so we can do brute force approach. I think we can just do, let's say, DFS for each rotting orange. If the size of the grid is much bigger than 100, then we need to come up with another approach that takes more less time, more efficient way. Okay, now we have the idea. So let's just do that. Let's just do some coding up. Wait, let me take some minutes to consider it more. So my idea was, so first scan the grid from top left to bottom right and find rotting oranges. And then for each rotting oranges, run DFS and update the grid. Okay, let's write some code. First, we have the grid and we can modify the grid. So the first we can scan grid, and then for each run DFS. Since we the number of cells in the grid is at most 100, we can simply do recursive DFS. So I think it's okay to define DFS. So DFS, and it takes row, column, and let's keep it path for now. And now this question asks us to how many times we need to consume to make all the orange rotten. So after running DFS, we scan the grid again. Okay. If so, let's write. If there is no wait, Wait a second. Let me read the question again. It says return the minimum number of minutes. So we should do that in, let's say, BFS. And I think it's better to come up with another approach. So standard grid and it's better to do it for each turn. Update grid. And after each turn, scan the grid. Scan the grid. Then, if there is no fresh orange, returns minutes. If is no update, returns -1. Okay, this is our basic approach. So let's begin. Let's first start the turn. For turn in range 1, let's say so while true turn equals start with 0, turn plus equal 1. So before that, before increasing turn, we scan the grid. Before that, we should have the n equal length of grid, m equal length of grid of 0. If not n, return -1. If not n, return -1. For I range of n, for m in range of 4. So first, let's create the next grid equals let's copy it from copy this copy of grid. We need this copy because the array list of Python is mutable, which means if we if we do this, it means next grid is pointing to grid. So if we update next grid, then grid will be also updated. So we need to do def copy. Now let's scan and let's check it. If grid of I, j equals 2, I, j -1 to the edge case. to do and 0, 0 case. And we have the has fresh equal false. We update the has false. If fresh true. If not has fresh, then return turn. Then let's copy and paste the scan and the comments. So if the if 0 is greater than if 0 is less than I, then greet I equals 1. Then we can update if I is less than and minus 1 and greet 1 next equal to if do the same thing and if m minus 1 and greet of 1 greet I plus 1 equal to in this way we are going to update the grid and finally we update the term. Now let me think. If there is no flash from the grid, then we can return the term. In the first term, which means return equals 0, then we can return 0. And in this code, let's walk through the code. If the grid has no fresh orange, then what happens? Let me walk through the code. Now, next grid is copied and has fresh equals false. We go through the lines and we pass all the code and exit from the 2 for loops. Then has fresh equals now false and return 0. Okay, that makes sense. And after that, we can increase time by 1. And return the minutes. If there is no fresh orange, return the minutes. And if there's no update, return -1. So we need to check that. So next is next different. So we are going to check if the next grid is different from current grid. Or I in range n, or j in range of n. So if grid n m is different from next grid I j, then is next different equals true. If it's not is next different, return -1. Okay, let's run the code. But before that, we should walk through the code to check if I made a mistake. So the length of grid equals n, and if not n, return -1, and m is grid, the length of the column. And if not m, which means the column size equals 0, returns -1. And we start with time equals 0. And while true, we first copy the grid, and then it has fresh equals false, then scan the grid I j, and if we found 1 has fresh equals true and grid equals 2, then edge case. So by having if clause, we did edge case. And for each time update the grid, so I update the grid. And 2 equals 0 case, so I also handled the 0 case by if 0 is less than I. So it's okay. Now we walk through the code. We continue walking through the code. A equals to grid if has not got return true, then if next different. So we check if the next grid is different from current grid. Okay. I found a mistake. I j is different equals true. If not is next different, then return -1 and update time. Okay, run the code. Oh, oh I found a typo. Hmm. So we got time limit exceeded. Let's see what happened. I guess while true loop is the cause of time limit exceeded. But I'm not sure why it happened, because in the end we have 2 types of end. The first type of end is it has uh, it has not fresh. So has fresh is false. Oh no, I I realized what the mistake I made. The mistake I made is grid equals next grid. Okay, let's submit the code. Yay. Okay, that's it. Thank you for watching.